about arithmetic sequences. You guys have done regular sequences so far and recursive sequences. An arithmetic sequence is special because it's doing something every time. What do you guys think is going on in here? The pattern, yeah. What are you adding each time? 2, good, nice job. You're adding 2 each time, very nice. So, when we are looking at an arithmetic sequences, you're always going to be adding. Or you're adding a fixed amount every single time. Now, we have a formula for an arithmetic sequence. If you guys were taking the readings class, you would have to memorize it, but right, you don't have to. I'll give you guys the formula to use. When we're looking at an arithmetic sequence, right, a sub 1, this part right here, is always going to be the first term in the sequence. The n is going to be the term you want. And the d, this is called the common difference. And that's basically what you're adding. So a lot of times we're just going to ask you guys, they might give you a problem and say, is this going to be arithmetic? And then they might ask you, what are you adding each time? What's the common difference? So the first thing you want to look to see, if you look at your pattern, what's going on in it? Are you adding? Are you multiplying? Good, we're adding 2 each time. It's consistent. So if we're adding 2, right, that means it has to be arithmetic, and the common difference is going to be 2. It's just what you're adding every time. What do you guys think is going on in the next one? Perfect, good. So you're really subtracting 3. Subtraction, so you're subtracting 3. The way we can represent that though is, since you're like minusing it, it's basically like adding a negative. So it's going to be a -3 that you'd be adding. Oh yeah. Oh, thanks. Does that make sense to you guys if it's negative or just like adding a negative?
Physics interruption. Attention seniors, if you were picked as a class favorite and haven't taken your picture, please meet in front of Mrs. Nathan's room at this time.
Oh, probably MHS students. Yeah. It's not until like after April break that we're starting. But you got time. Okay, so when you guys are looking at this one, which one of these has a common difference of 4? Okay, take your time. Which one of these is adding 4 each time? What you kind of think about it? Or it's got to be addition, not multiplication. Alright, Vinny, you're right. It is choice 3. Because what's going on in this one, yeah, I think maybe in here you guys are looking at adding. But if you took 4n and you added 4, are those things alike? Are those like terms? No. Alright, so when you go from 4n to 8n, it's multiplying by 2. So it can't be choice 1. Same thing in here. This one's being multiplied by 4. Right, so we can't do that one. This one is being, let's see, what's going on in here? We're kind of like adding like 4 times 4 in this one, bless you. Yeah, so we can't do that one. It's got to be a consistent thing that you guys are adding. Vinny, good job with that one. Yeah. This one you're definitely adding the same amount each time. From 1 to 5, that's 4. From 5 to 9, that's 4. 9 to 13, that's 4 too. Okay, so this one we were adding 4. Right. What do you guys think for this one? What's the common difference? Add 4. Nice. Next. Your common difference is 4. Nice. Alright, well, sometimes then I ask you guys, to find the common difference, like if they don't give it to you, and maybe you need to find some terms in sequence. This is like one of the very first things you guys did. If you're given a formula and they ask you for like the terms in sequence, or maybe like what's happening in there, what we have to do is start with that like a sub 1 is your first term? Right? So if we want to find the first term where you see an n, you just put a 1 in its spot. So it looks like a 6 times 1 plus 3. What would that give you guys? 9, good. So 9 is the first term. How can we get the second term? 7, 2, good. So we're going to a sub 2. So we got 6 times 2 plus 3. Good there. Good job. Very nice. And remember, somebody asked this, that like, once you guys get the pattern, you have to keep going and going. No, but you need to always have 3 to make a pattern. Right? You can't have just 2, because 2 could be a coincidence. You don't really know for sure. You always need to do 3 at least. So a sub 3, we're going to plug in a 3. Good job. Okay, so we got 18 plus 3 is 22. Great. Okay, now we can look to see, because our real question asked us to find the common difference. So what was going on between each of our terms? Adding 6. Great job. All right, so since you guys were adding 6 each time, the common difference is going to be 6.
Wait, we already just equals just subtraction too?
It has to be equal to negative 6. Yeah, you just make the sign negative. Good question, Nick. Now, sometimes they like you guys to make a formula. This is a little bit trickier, but not too bad, right? So whenever it says anything about making a formula, right, you want to use the arithmetic sequence formula. This is what I said I'd give to you guys. A sub n equals a sub 1 plus n minus 1 times t. So when you guys are looking at your pattern, the first thing we want to decide is what's going on in there. Good job. Adding 2 each time. Perfect. You're adding 2. Okay. So once you guys figure out that you're definitely adding, it's got to be an arithmetic sequence. So we can use our arithmetic formula. Okay. So a couple things in this formula. The a sub 1 is always your first term. So when we look up at our pattern, what's your first term there? What's your first number? 10. Good. So this is going to go in place for 10. Okay. Now, when you guys are finding a formula, all right, when you're doing something with like the nth term, right, n is going to stay n. All right, whenever you're coming up with a formula. All right, how did you guys find the d? What did that represent? Nice, the change in the numbers. Yeah, what you're adding. So what would you put in there? 2. Good job. Right, because the 2 was what we were adding between each of our numbers up here. So if we want to figure out what this formula is, we're going to have to take what's on the outside of our parentheses and distribute it through. It just looks weird because usually you guys see it in the front of the parentheses, not in the back. Right? It's okay, as long as it's connected, we're still going to distribute. So 10 plus 2n minus 2. Do you guys have any like terms that we can combine there? Good, 10 and the 2. What's that going to be at? 8. Good job. So we got 8 plus 2n is going to be the formula to represent the sequence. Oh, yeah, right. Yeah. Oh, you could do that too. Absolutely. Yeah. So especially with multiple choice like that will work, but if it's not multiple choice, then you have to use it. Good job. Abby, can I share your idea? Good. Abby said, well, she kind of started doing this before we looked at this formula. She kind of used that this was the first term, this was the second term, this was the third term. So what she did was she looked to see if you plug in 1, which one will give you a 10. So she plugged like a 1 into all these where you saw an n, and she actually did them out. So if you did 8 plus, this would just be 2. 8 plus 2 would give you 10. And then she plugged in a 2 here and did 8 plus 2 times 2 would give you 4, which would have been 12. So she kind of used that idea to work backwards. That was really good. Good job, Ella. All right. So another way you guys can kind of see these come up is like finding a specific term in the sequence. Okay. If you guys are asked to find a term, especially something like this, find the 25th term, you guys want to keep adding something over and over and over 25 times, or maybe like 100 times? You would? Oh, it could work. It would take a long time. So what we can use instead is using our formula, and that's going to help you. So let's look and see what's going on in here. What do you guys think is going on? Is it a positive 3 though, or a negative 3? Positive. It's positive. Oh, good job. You're so smart. We're adding a positive 3. Great. So as soon as we know we're adding each time, we're going to use our arithmetic sequence formula. A sub n equals a sub 1 plus n minus 1 times c. We're going to fill in some of these things that we know here. The a sub 1 is always your first term. So when we look up in our sequences, good job, Dad. First term, the a sub 1 is negative 7. And I'll put that in its spot. Now this time we're not looking for the formula. We want the 25th term. N is always the term you want. So if we want the 25th term, what do you guys think you can put in place for n? 25, perfect. So 25 minus 1. And then your common difference, what was going on here? 3, good job. Okay. Now this time you don't have any letters anymore, right? You have something in for every single part. So just make sure we're doing some PEMDAS here. Okay. Good job, yep, 24 times 3. Did you guys calculate there? Oh, you got 72, perfect. And then plus a negative 7, what are we going to get? That's like 63? 65. There we go, 65. So 65 would actually be the 25th term of the sequence. So if you guys did that out, kept adding 3 over and over and over again, right, 65 would have been that term. All right, let's try another one here. So this next question asks you guys find the formula for the sequence. Well, let's first see what's going on in here. What do you guys think for the pattern? Plus 2. That's miracle. Good job. So we're adding 2. Okay. So if we're adding, we're going to use our arithmetic sequence formula. A sub n is a sub 1 plus n minus 1 times c. Let's fill in some things we know here. Anybody know what we should put in place for a sub 1? Good job, 1. Right, nice work, because 1 is our first term. Okay. Well, do we know what term we want, or are you guys finding a formula? Yeah, so when you are looking for a formula, n stays n. Okay, so we're going to keep n and n. Okay. What do you guys think for the d? Good, 2. Nice job. Okay. All right, so to simplify this, we're going to distribute through. We should have a 1 plus 2n minus 2, yep. And then we want to combine some like terms. So it should be 2n minus 1. Good job. So this would be our formula. What do you guys think so far? Pretty good. Pretty good? Easy? How does this crew feel? Sorry. Can we go back through? Just make sure once you plug everything in, you take what's on the outside and you bring it through. That's it. So that's how I got like the 2n and minus the 2. And then just combine like your 1, your 1 and the negative 2. Because those are the only things that are like in there. Oh yeah. Okay. Alright. This one's a little bit tricky, right? This would be like the hardest kind of thing I would give to you guys. I'll let you ponder this for a second. Find the number of terms in the sequence. So what this means is, you know that 7 is your first term, 10 is the second term, 13 is the third term, but these dots, you know, there's a lot of stuff between there. We don't really know how many. And we know that some term, we don't know what term, is going to be 55. How do you guys think we can, or like, do you know anything about this sequence at all yet? Good, I'm going off by 3, awesome. So at least we know we're adding 3 each time. Right, so since you're adding, it's got something to do with our arithmetic sequence formula. Okay, let's see. We can figure something out here. Do we know what the a sub 1 is? 7. Yeah, good. A sub 1 is 7. That's our first term, so you know this is 7. Do we know what term we're looking for? No, they don't really tell us that, so N's always what term you're looking for. I'm going to keep NN because I don't really know what it is. Then what could you put in place for the D? Good. All right. Now, there's a tricky part about this. How can we figure out how many terms, or what can we put in place for a to n? Good, Jess. 55. Because we don't know the n value at 55. How can we figure this out? Any ideas? You did it in your head? Holy cow! I guess you could do that in your head if you.
Just take that one.
Did it? You kept adding 3 over and over? Alright, let's see if we've got the same thing. So we take our 3 and bring it to a distribution. And we're going to get 7 plus 3n minus 3. And before we can figure out what n is, let's combine some like terms. It'll make this easier. So 7 minus 3 is going to give us 4, good. And then we have equals 55. Alright, let's figure out what n is going to be, and maybe that can help us figure out how many terms we would have. Would you guys solve this for n? What do you have? 17? Matt, is that what you got when you kept adding over and over? Good job, yeah, nice. Alright, so this n, it tells us that a sub 17 is going to equal 55. So there's got to be 17 terms in our sequence to get that far. Nick, could you simplify it? This will be like the hardest thing you guys would ever get. And now, if this is confusing for you to use a formula, if you knew you were adding 3 like over and over and over again, could you just keep adding 3 until you got to 55 and count them off? Yeah, it's a lot of work, or you could use this. I'll come help you. Just like your homework. The 55 is like what age? So the n is? N is like the term, but we don't know like where this 55 happened. We don't know the term that this is. Oh, so you put 55 over here. That's why, yeah. Right. The 55 is like the answer. You don't know what the n is here. So it's kind of like you got to like work backwards to solve for it. All right, guys. Here's your homework. It's on page 256. 3, 5, and 6. 9, 10, 11, and then 2. Well, listen, for these, all you're going to do is look at it and you're going to say, are you adding or are you not adding? So it goes, yeah.
So it's easy?
Yeah, it's easy. Okay.
So maybe I'll do homework.
You should do homework with me.
Barbara, may I go to